Welcome to creating story problems with dividing whole numbers by fractions. Let's be sure we have these notes in front of us so that we can begin our lesson. Our learning objective for today says I can create word problems for dividing whole numbers and fractions. So let's go ahead and talk about the left side of our notes, our vocabulary. Our first vocabulary word is fraction, so we've seen this before. A fraction is a part of a whole. Second word, dividend, means the total amount. And remember, these are the numbers that go inside of our division bar. Our third vocabulary word is divisor. That is the amount going into the dividend. And remember, this is the numbers that goes outside of the division bar. And the last vocabulary word, quotient, it means an answer to a division problem. So let's go ahead and take a look at our key concepts on the right hand side of the notes. So this is a problem that you may see, a whole number being divided by a fraction. And what I want to do is I want to go ahead and break down what the different parts are. So the 10 is our dividend. That's our total amount. It's being divided by 2/3. That will be our divisor. And then once we do the division, the 15 becomes our quotient. That becomes the answer to our problem. So you cannot mix it up. You can't say that the 2/3 is your dividend or the 10 is your divisor. You cannot flip them. If the problem gives you the 10 coming first, that has to be my dividend. If the 2/3 comes second, that has to be your divisor. And when you solve the problem, you get your quotient. So when we want to write a story problem for a given division problem, our first step is to come up with a story and write a story that comes to our mind. Our second thing would be to ask a question about the story that you created. And the last part is to interpret the solution. And basically the word interpret is a fancy word for saying, like, what does the answer mean? So we're going to use these key concepts to go ahead and write story problems for the following examples. Alright, so this problem, for example 1, looks kind of familiar because it's the same problem that we use in our key concepts. We notice that we have a total amount, which is our dividend, and we have our divisor, which is 2/3, and we have our answer, which is 15. So I'm going to create a problem using that information. I'm going to create a character, so let's call that character John. And I'm going to say John has 10 whole pies. And the reason why I started with that was because 10 was my total amount. So that's the total amount that John has. And then he cuts. Keyword for dividing. Cut is a keyword for dividing. He's going to cut the 10 whole pies up into 2/3 of a whole servings. Okay, so he's going to create little servings that each are 2/3 of an entire whole pie. Okay, so that's our story problem that we just created. Our second steps told us to go ahead and ask a question. So the question I'm going to ask myself about this is, how many servings are made? So that is the question I'm going to ask myself about this problem. I want to know how many servings are made based off of the whole story problem. And then now I'm going to interpret the solution. Because they'd solved the problem for me, I'm going to say that there are 15 servings made. So I just told you exactly what that 15 meant. It meant servings because that's what the problem was about. Alright, so since we already know the answer, let's go ahead and prove that the answer is 15 using a model. So I'm going to just write maybe down here. I'm going to say 10 over 1, which is my fraction, divided by 2/3. And I notice that my denominators are 1 and 3, so I need to create a model that is 1 by 3. 1 high by 3 blocks long. Alright, so that's just 1 pi right there. The problem says I need a total of 10, so here's our second pi, our third pi, fourth pi, fifth pi, sixth pi, our seventh pi, our eighth pi, 9 pi's, 10 pi's. I'm going to label that 10. That is our total amount. Alright, so now that I have a total of 10, what I want to do is I want to go in and shade all 10. Alright, so now that all 10 of the pi's are shaded, I'm going to go ahead and create another pi to the side, which is still the same size, 1 by 3, and that is going to be worth 2/3. And I'm going to shade 2 of the 3 in this case, because it's not the entire thing. Now what I want to do is I want to go ahead and circle how many times the red can go into the blue. And it can go in a lot of times, so here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that's where we got the number 15 as our quotient. We can also use the algorithm, which is 10 over 1, times the reciprocal of 2/3, which is 3 over 2. And we can cross cancel. 2 goes into 2 once, 2 goes into 10 5 times, and 5 times 3 is 15 over 1, and we still get 15 servings. Alright, example 2, let's create a word problem for 5 divided by 1/4, which is equal to 20. So our 5 we know is our dividend, or our total amount, and we're dividing it by our divisor, which is 1/4, and our quotient is 20. So let's create a problem here. Let's say Sally, that's the person of the story, Sally ran a total of 5 miles. That's her total amount. Okay? So when you run, you're running around a track, so each lap around the track is 1/4 of a mile. So I just wrote a story problem based off of the dividend and the divisor. Now what I want to do is I want to ask myself a question about that. The question will be, how many times did she run around the track? So she ran a total of 5 miles total. She ran around the track a certain amount of time, but each time around the track was 1/4. So let's go ahead and interpret the solution. It's she ran around the track 20 times. Alright, so now that we've written our story problem, let's go back and check how they really got the number 20 using the algorithm, which was 5 over 1 divided by 1 over 4, and I know that my model needs to be a 1 high by 4 long. So here's 1 high by 4 long, and that is 1 mile around the track, but I need 5 of them, so I'm going to need to draw more. There's 2 miles, 3 miles, 4 miles, and 5 miles. So I'm going to take some time to go ahead and shade inside of it. Okay, so I shaded all 5 of the miles around the track. I'm going to label that 5. I'm going to leave a space, and I'm going to need to draw another mile right here. But I'm not going to shade the entire thing. I'm going to shade 1/4 of it, because that's once around the track. So 1/4 of a mile. Okay, so I want to see how many times the blue can go into the red. So let's count. So there's 1 mile, or 1 time around the track, 2 times around the track, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So a total of 20 times are on the track. Now we can go back and check with our algorithm. 5 over 1 times the reciprocal of 1/4, which is 4 over 1. You can't cross cancel, but 5 times 4 is 20 over 1, so we still get the same answer of 20. Okay, so the next example, we have 3 divided by 3/4, which is equal to 4. Our 3 is our total amount, or our dividend. 3/4 is our divisor, and our quotient is 4. So let's go ahead and come up with a story. Let's say Jamie is making cookies. The recipe calls for 3/4 of a bag of sugar. For one batch. She has a total of 3 bags. Now remember, total, that's the dividend, and I'm using the same number. Now let's go ahead and ask ourselves a question about this. Let's ask ourselves, how many batches of cookies can she make? So given the amount of ingredients that she has, how many batches can she make? And after looking at the answer, we know that she can make 4 batches. So given what she has, she can make a total of 4 batches. Alright, so now let's go ahead and check our answer with drawing a model. So I'm going to write down here, so 3 over 1 divided by 3 over 4. And I'm going to circle our denominators, which is 1 and 4. And create a model which is 1 high by 4 long. Or, I mean, you can do the opposite. You can do 4 high by 1 long. So there's 1 by 4. Alright, so this right here is 1 bag of sugar. But she needs more than 1 bag. She needs 3 bags. So here's the second bag of sugar. And here's the third bag of sugar. So let's spend some time going and shading in. Okay, so now that we shaded all 3 bags of sugar, let's go ahead and draw our second model, which is still a 1 by 4 model. And this is worth 3/4. And it's not the entire thing, it's only going to be 3 out of 4. So I want to know, this is the amount for 1 batch. And I want to know how many can go into what she has. How many blue can go into the red? So she can make 1 batch here. Here's another 3, so that's another batch, and she's got another batch here. So 1, 2, 3, 4. She's made 4 batches. If we want to check with the algorithm, that's 3 over 1 times the reciprocal of 3/4, which is 4 over 3. I can cross cancel. 3 goes into 3 once, 3 goes into 3 once, and 1 times 4 becomes 4 over 1, which is the same thing as our quotient. So go ahead and pause the video, complete the problem, and then play it back for some feedback. So we have to go ahead and solve the problem. So when you solve 6 divided by 1/3, you should have got 18. Now, there's many different word problems that you can create. Just make sure that when you create the word problem, the 6 is the total amount of something that you have. So like, I had $6 or something like that. That's the total amount that you have. And then you're going to divide it by 1/3, and your answer, your quotient, should have come up with 18. And then for letter E, just make sure when you do the division, it should have been 7 1/2. And then when you write the story problem, there could be any problem that you want. Just make sure that the 5 is the total amount that you come up with. And then the 2/3 is what you're dividing your 5 by. And then your quotient, which is 7 1/2, is the total amount of groups that were made. So now that we've completed the video lesson, go ahead and self-assess yourself and let us know how you feel. If you have any questions about anything in the lesson, please write them down and then bring them to class tomorrow so we can discuss it.